Okay.
So if we do a histogram in Desmos, which I'm actually going to use Desmos today, so it's interesting that you brought that up. So we're going to first say that we're going to let L be a set of data. So we're going to say L equals, and then in parentheses, make sure I'm doing this right. Oh, they got to do square brackets. Oops. Nope. And then let's say we do 1, 2, 2, 3, 5, 7, 9, 9, 9, 10. Okay, so there's our list, right? So L is a 10 element list. And then after we press enter, we're going to do histogram. So to get to the histogram function, we go under functions over here, right? So to get functions, if you're just looking at Desmos, you're going to go down here to show keypad. We're going to go over to functions. We're scroll down to histogram. And we're going to say we want a histogram of, so in parentheses, it's got data set and bin width. You can see underneath here. So let's say I want to do a histogram of L. And I want a bin width of 3. So it's going to group our stuff together for us. And it might get mad because this is the lowercase L and not an uppercase L. Let me go back to this and change this to an uppercase L. There we go. So with this, I've got L, which is a width of 3. And then center alignment, we'll do left alignment. So you can see here, if I pull this over, I did a bin of 3, so that means it's going to group all of these numbers from 1 to 3 together. And if we count, we've got 1, 2, 3, 4 of them. 1, 2, 3. So there's 3 numbers within here, right? Because we're counting the number 2, then 5 and 7. Oh, I see what they're doing. They're going, when they do a bin of 3, they're going from 0 to 2, because 0, 1, 2 is 3 numbers. So that's why they're showing to 3, because the 1, 2, and 2 gives me 3 numbers. And then the next bin is going to go 3, 4, 5, which there's 2 numbers there. And you can see from here, it's going from 3 up to 6. It's not including 6. And so it's got 2 numbers there. The next bin is going to be 6 and 7. Which there's only 1 number that falls in there, which is why it's only 1 tall. We can see that's 1 tall over here on the left-hand side. And then our last bin has 9 numbers, or excuse me, not 9. I'm going to talk about it. It has 4 numbers in it, so you can see how it's going up. So that's how, and I'm doing left align because it's to the left of where the bin starts. You can look at relative, which is showing the bar height, and then we can have density, but really we're just looking at counts, which is what we care about. And then if you did center align, that's where they're centering it over the beginning of the bin number, but that's confusing. So I like left align. So that's how you can use Desmos to create a histogram. You can also do, instead of a histogram, we can do a dot plot. So if we do functions, going down, we can do a dot plot. And again, dot plot, we would do set L with bin width 3. And you can see how these dots are showing how frequent these numbers occur, right? And then another thing we can do is we can even do a box plot. So if we go to the function, when we go down to box plot, we want the data set, which is going to be L1. And we're not going to offset and do anything like that. If we didn't want to exclude outliers, we could unclick this. They're not any outliers, but you can see how it shows that our mean is 6, our lowest number is 1, our highest number is 10. So there's lots of things that we can do with this. with this data here in Desmos. But today we're going to talk about standard deviation, which we're going to show how you can do that with standard deviation as well.
Thank you.
It won't make a bar graph, but it will make a histogram for you. And it will make a box plot. So there you go. All right, let's get into 7.4, 7.5. I'm only going to do 7.4 today because I want to make sure that we have enough time. Not even enough time, like I could shove it all into today. But the problem is I don't want to rush this. I want to give you some time to think about it. And so we're going to do all of 7.4 today, which is variation and standard deviation. And then on Thursday, we're going to do 7.5, which has to do with the normal distribution and margin of error. And so it's good to understand standard deviation and kind of like sit with that for a little bit. I encourage you to do the homework for this section too. So that when we come back together on Thursday, you are familiar with standard deviation, so you understand how it applies to the idea of a normal distribution. So variation is a measure of central tendency. We kind of listed, when you think about central tendency, we've already looked at mean, median, and mode, but now we're going to get into variation and standard deviation. So measures of central tendency do not tell us anything about the spread of the data. Two data sets can have the same mean or median, but have drastically different spreads. And when we talk about spreads, it's how far apart the data is. Is it grouped close together? Is it really far apart, right? There's a huge variation between the lowest number and the highest number. The measures of spread are used to assess the dispersion or variation in a data set. And we'll look at three commonly used measures of variation: the range, the variance, and the standard deviation. And we also talked about the interquartile range. So we've touched on that. We might come back around to it. So the range, again, is the difference between the largest and smallest number in a sample or data set. So if I had, say, data set 1, 2, 5, and 8, the range would be 8 minus 1, which is 7. Another method to describe the spread of a data set is to find the deviations from the mean and then derive a measure of variation. The deviations from the mean are found by subtracting the mean from each number in the sample, and the sum of all the deviations from the mean will always be 0. So we're going to calculate standard deviation by hand twice, but then I'm going to show you how to use Desmos to calculate it. And my expectation is that you're going to use a calculator to calculate standard deviation, because it's crazy to do it by hand. It's not necessary, but it's also important for us to understand where that calculation is coming from, and that's why we're going to do it by hand. So the most useful measure of variation is the standard deviation. And before we look at the standard deviation for a set of data, we must find the deviations from the mean first. This is found by subtracting the mean from each number in the sample set. So in order to do that, we have to find the mean first. So we're going to calculate the mean. So remember, to find the mean, we are taking the data points and we are adding them together. And we are dividing by how many we have. So we have 1, 2, 3, 4, 5 data points. And so adding those all up, we'll have 230 divided by 5, which gives us a mean of 46. Now, in this table, this is just a way for us to organize our data. The top row has our actual values in our data set, right? So you can see 32, 41, 47, 53, and 57. So to calculate the deviation from the mean, we subtract the mean from each number, but you're going to start with the number first, then subtract the mean. So some of these values are going to be negative and some of these values are going to be positive, because the values that are below the mean will give us negative when we subtract, and values that are above the mean will be positive. So we're going to do 32 minus 46, which gives us negative 14. 41 minus 46 gives us negative 5. 47 minus 46 is 1. 53 minus 46 is 7. And 57 minus 46 is 11. We're going to find the sum of the deviations. This should equal 0, but it's always good to check just to make sure. And when I add these up, negative 14 plus negative 5 is negative, what is that, 19? Plus 1 puts us at negative 18, plus 7 brings us down to negative 11. So then when I add 11, I do in fact get 0, which is great. We just are checking that it is 0. So from here, we're going to look at calculating the variance. So we first calculated the deviations from the mean. That's this row. And we're going to use that information to calculate the variance on the next page. So calculating the variance, to calculate the variance V of n numbers. When we say n numbers, that's just the number of numbers in a set of data. So with our data set, we have 32, 41, 47, 53, and 57. Because there's 5 numbers there, we would say that n equals 5. So in order to calculate the variance, we first find the mean, which we did. We know that our mean is 46. And then you're going to subtract the mean from each number, which again, we did on the previous page. I want you to notice that I copied that information down. So we've got our data points in the first column, the deviation from the mean in the second column. So remember, in order to do this, that negative 14 came from 32 minus 46, right? We subtracted the mean from each data point. And now we're going to square the difference found in step 2, right? I'm right here. So we're going to square the difference. So if we got negative 14 as the deviation, we're going to square that. So we're going to take negative 14, we're going to square it, which gives us 196. We're going to keep doing that for all of these deviations. So negative 5 squared is going to be 25. 1 squared is 1. 7 squared is 49, and 11 squared is 121. Step 4 says find the sum of the squares in step 3. So we're going to add all these up. Let me pull up my calculator. Stop sharing for just a minute. Okay, so you can see I've got a calculator here. We're going to add these up. We're going to do 196. Oops. 196 plus 25 plus 1 plus 49 plus 121. And that gives me a total of 392. And then in order to, you're going to obtain the variance by dividing that sum in step 4 by n minus 1. So remember, n is the number of data points we have. So n equals 5 here. So to calculate the variance, we're going to take that sum, 392, and we're going to divide it by 5 minus 1. So 392 divided by 4 gives us 98. So the variance is 98, which doesn't really tell us a lot because it's a squared value. And so in order to actually get an idea of this data, we then want to calculate the standard deviation. So to calculate the standard deviation, we take the square root of the variance. So the standard deviation is the square root of the variance, so the square root of 98. Which gives us 9.899494937. which we are going to round to 9.899. In your homework, it's going to tell you how many decimal places to round to. The reason why I am keeping so many decimal places right now is because if I rounded to the nearest tenth, that's 9.9. If I rounded to the nearest hundredth, it's going to be 9.90. So again, I'm just showing what our standard deviation is. Typically, they'll have you round to either 1 or 2 decimal places, the nearest tenth or nearest hundredth. So I have a more formal definition of standard deviation and variance on the next page. This is just how in mathematics we define this. So we've got kind of a more meaty definition, for lack of a better way to say it. So the sample variance is a way to measure how spread out the data is. The sample variance is just the variance in a sample, and it gives you an idea of how much your sample differs from the average population or mean. The variance on its own, like I said, is not very informative, but we use the square root of the variance to find the standard deviation. So we have these formal equations or formulas, to find the variance. So it says the variance of a sample of n numbers, x1, x2, all the way to x sub n. That's just giving us our data set with mean x bar is, and it shows that what they're doing is they're finding the sum of the squares of the data, right? It's the sum of x squared minus n minus the mean squared. And so all that's showing you is it's taking, remember in order to find this, we took each data point, we subtracted the mean from it, and then we squared that value. That's all that is doing right there. And then we divide it by n minus 1, which again, we don't encounter those types of formulas very commonly in our everyday life. And so therefore, I don't rely on it in order to explain to you how to find this. But remember, if we think about our steps, it's finding the mean, it's subtracting the mean from each data point, it's squaring that, and then it's dividing by 1 less than the number of data points we have. That's all that this formula is telling us to do. But again, to find the variance, we square the deviations from the mean, so the variance is in squared units. To get the same units as the data, we take the square root of the variance, which gives us the standard deviation. So again, all they're trying to show you here in this row is that in order to find the standard deviation, you're taking the square root of the variance, right? Because this formula inside here is the same as that formula for the variance. The standard deviation is the most commonly used measure of variation. The standard deviation is a measure of the variation from the mean, and the size of the standard deviation tells us something about how spread out the data are from the mean. So if the standard deviation is big, then your data is more spread out. If the standard deviation is small, then your data is closer together. So as you remember, we talked about this next definition has to do with outliers. And so previously we had defined an outlier as, let me get my definition so that we have it accurate. So previous definition for an outlier had to do, oops, spell previous properly. Was equal to 1.5 times the interquartile range, right? Well, now that we know how to find the standard deviation, we can categorize values as being outliers if they lie more than 3 standard deviations from the mean. So at least 1/2 of the data points will be within 1 standard deviation of the mean, with most within 2 standard deviations. If a data point is more than 3 standard deviations from the mean, then it is considered an outlier. And we'll talk about outliers more when we get into normal distributions. But remember last week I said, okay, this is the definition we'll use for now, but then we'll get a better definition for outliers. So again, previously we said an outlier was any value that was 1.5 times, that was greater than or less than 1.5 times the interquartile range. But now we have a new definition, which we will use on Thursday. So we're going to practice finding the standard deviation for the following set again. I'm going to have us do this by hand because, again, it's helpful in order to understand this, but this will be the last one that we do by hand. So remember, to find the standard deviation, we first have to start by finding the mean. So I want you to take a minute and find the mean. Okay, so to find the mean, remember we're going to add the values up. So we're going to do 1 plus 3 plus 3 plus 5 plus 8. So when I add these up, I get a sum of 20. So we're going to take that sum and I'm going to divide it by the number of data points we have. So there's 1, 2, 3, 4, 5. So we're going to divide by 5, which gives us a mean of 4. So again, if we're thinking about our steps, step 1 was define the mean. Step 2 is going to be define the variations from the mean. Which means that we are just subtracting the mean from the data points themselves. I like to do a little table for this only because it helps me to organize my information. So I'm going to do 1 minus 4, which gives me -3. 3 minus 4 gives me -1. And remember, you're starting with the data point, then subtracting the mean from it. Again, 3 minus 4 gives me -1. 5 minus 4 gives me 1. And 8 minus 4 gives me 4. Then I'm going to square the variations. Step 3 is square the variations. So I'm going to take -3 squared, which is 9. -1 squared, which is 1. I know this 3 inside here is not very well written. -1 squared, which is 1. Again, I know that I have the same variation, -1 twice in a row. You can't just use one. We have to use all of them. Okay, so that's why you'll see I'm squaring -1 2 times because I have 2 of them. Now I'm going to square 1, which also is 1, and then I'm going to square 4, which is 16. The reason we square it is to get rid of the negative values. Step 4 is to find the sum. The squared variations. If I could write properly. So we're going to take those values, 9 plus 1 plus 1 plus 1 plus 16, which gives us a sum of 28. And then we divide that by n minus 1 or 1 less of the data point. So we're going to find the variance. It's going to be 28 divided by 5 minus 1, or 28 divided by 4, which gives us 7. So the last step is to find the standard deviation. Which is just the square root of the variance. So we're going to do the square root of 7, which gives us 2 point. Let's pull my calculator up. Use the square root of 7, which is 2.645751311, and we're going to round that to approximately 2.65. So a lot of steps there, right? Do we have to do this by hand every time? No. It's just good to know where this information is coming from, but we do not have to do it by hand. So if we go back to Desmos, and I'm going to start with Desmos, and then I will show you how to do it on a graphing calculator as well, because depending on what you have to use, Desmos, remember, is free. So I will start with that, but I'll also show you how to use a graphing calculator to find the standard deviation. So if we go to Desmos, we're going to want to first, we're going to go down here to show keypad. We're going to go to functions, and we're going to scroll down to under statistics. Remember, we talked about mean, median, and then you can see this STDEV, which means standard deviation. So we're going to click on that, and then we're going to input our numbers just like we have. So we're going to do 1, 3, 3, 5, 8. And you can see that once I do that, I can find that the standard deviation is just like I found going through all the steps. So it's, again, you're still coming up with the same value, okay? So if we go over to our so again, just the step, just to remind ourselves, how do we do this? We went down to the show keypad, we went to functions, we scrolled down to statistics here, and we chose standard deviation, okay? You can see that there's variance here. We can also do that as well. We don't really care about that. We're just looking at the standard deviation, okay? So if we go over to our graphing calculator, how would I do this with that? So let's go back to the graphing calculator. So in order to enter this information to a graphing calculator, we first have to enter it into a list. So in order to do that, we're going to press stat, and we're going to press enter when it's on highlighted on edit. So we'll press enter. Now I've got old data in here, so give me a minute while I clear this out. To clear something out, you would press the up key. See when the L2 is highlighted, we press the word clear, and we press enter, that clears it out. We're going to go over and clear out L1. So if I press the left key, I'm going to go up to L1, press clear, and press enter, and now it's cleared out. So from here, we're going to enter our data points again. So I'm going to do 1, 3, 3, 5, and 8. And so once I have my data entered in here, I'm going to quit, which I know seems ridiculous, but we've saved our data now. Okay. So I'm going to do second, and this mode key, again, you can see the word quit in yellow. I know that the second key triggers that because the second key is yellow itself. So pressing the second key and then mode gets you out of that window. And now we need to actually do standard deviation. So we're going to press stat again. we're going to go right to calc, and then we're going to go down to, oh, wait, no, that's right. We can do, I haven't done this in a while. I think one of our stats, if I remember correctly. So let's press enter. And then we need it to run on list L1. So we're going to do second, and then go down here to number 1, which is going to give us L1. And we'll press enter. And you can see it gives us a mean of 40, which we knew. It gave us a sum of data points of 20. We had 5 for our number, but then this SX right here, I can't really highlight it. But so if you look 1, 2, 3, 4th down on the list, SX is 2.6457, and that is our standard deviation. Okay. Later, if you were to take more stat classes, they would talk about this theta. We're not going to deal with that. Has to do with standard deviation for the population versus the sample. We're only worrying about the sample. Again, sometimes it gives you too much information, right? So there's our standard deviation right there. That's another way we can do it. Again, if we review those steps, let me clear this. So my first step was I pressed stat. I went into edit and I entered my list, right? So again, if you like, how did you get that in there? If there was already data in there, we pressed up on L1, we said clear, which cleared all that out. Then we entered it. So we're putting in 1, 3, 3, 5, and 8. And then once we have our data entered, we're going to say second quit. And then we're going to press stat again, go right to calc. With one of our stats highlighted, we're going to press enter. And then remember, because we put our data in list 1, if you put your data in, say, list 5, you're going to want to use that as, because you have to tell it what to run that function on. To get those list numbers, you can see that at the bottom of the calculator where our numbers are, there's also little letters written in yellow. So we've got L1 with the number 1, L2 with the number 2, L3 with the number 3. So again, if you entered your list into some other list, that's how you would grab that. But we went into L1, so we're going to press second to get L1. Again, in order to get the words that are written in yellow, you have to press the second key first. And then once we do that, we can press enter. And again, it gives us our mean. X bar is 4. And then the standard deviation is 2.64. So I've showed you how to do the standard deviation using Desmos, which is free. But if you have access to a graphing calculator, you can also do the standard deviation using the graphing calculator. So for this homework, again, I want you to focus on doing 7.4 first before I get into talking about the normal distribution, which comes from 7.5. So your homework, there is a homework assignment already listed in Eagle Online. It's on page 225. Again, in the assignment box, you know how I have it. It's listed out. It's from your textbook. I want you to try to do that before our lecture on Thursday, because calculating that standard deviation and understanding that process and being able to do that is really going to help you to understand the normal distribution. So in addition to doing that homework, if we look at what else we've got due, so on Wednesday, you've got your homework for 7.3 and the box plot worksheet due. And then on Thursday, you have the quiz 5 due, which is over 7.1 through 7.3. And then on Thursday is when I'm going to teach 7.5, which is the normal distribution and all of that. So again, I don't want to go through our whole time and get into all the information because I think it's just too much to do at once. So I'm just going to cover 7.4 today. And then we'll pick it up on Thursday where we talk about 7.5 and the normal distributions. So that's everything I got for you today. I hope you all have a good day, and I will see you on Thursday, okay? Bye.